Alright, so let's start off this video with an error already. I don't know how to spell square. So, there we go. Completing the square to solve quadratic equations. So in the intro to this video, I didn't do the quick checks. Instead, I left that to you. And I wanted you to focus on the idea that this strategy is used when other strategies, much more simple strategies, are not going to give us an answer that's easily calculated. Okay, so you're going to see as I go through the exercises, well, you'll see once we get there, but I'm going to point out when completing the square is actually not the right strategy, but we're doing it for the sake of practice. But given all the strategies that you have up to this point, there are certain problems in the exercise set where completing the square was pointless, and we'll get there. Okay, so let's go ahead and take a look at problems 1 through 6. So here they're just asking you to figure out what this missing n variable is to make this this trinomial a perfect square trinomial. So here is where you hammer down the system, and I'm actually going to end up skipping this step in problems 7 through 25. Here's where you hammer down the system of figuring out or calculating what that term is. So I'm being very explicit here. Okay, I'm going to take my b value divided by 2 and square it. So there's my b value divided by 2 and square it. I'm going to show you what the b value divided by 2 is. Then I'm going to show you what that number squared is. And that is the value that we're looking for here. So being able to just look at this and go, okay, 14 divided by 2 is 7. 7 squared is 49. 49 is what I need to have in this spot. It's going to become very important for all of the problems moving forward. Now, what's also key is that b, whether it is negative or positive, doesn't matter, because when you square it, we're going to end up with a positive value. So this tells us that we're going to have a positive value for n. Now, when we factor the trinomial into its perfect square state, the binomial squared, this sign absolutely matters, right? So we're going to have to be careful once we get to that step. So here, just check it really quick. Check my work. All right. So here the term should be 16. 18 divided by 2 is 4. 4 squared is 16. 40 divided by 2 is 20. 20 squared is 400. 6 divided by 2 is 3. 3 squared is 9. 24 divided by 2 is 12. 12 squared is 144. 36 divided by 2 is 18. And 18 squared is, I just moved that. Awesome. 324. Okay. 1 through 6, done. 7. Now we are given a binomial equaling a constant. All right, and what we're supposed to do is add that term n that we were looking for before, add it to our binomial so that we can make a perfect square trinomial, right? And you're going to see this little cranky face here. Now, what I did is I worked this out after the cranky face here to show you why that's there. So in this case, using the perfect square, solve by completing the square strategy, we need to add 16 to both sides, because 8 divided by 2 is 4. 4 squared is 16. So we're going to add 16 to both sides. Now, I wrote the cranky face here because I realized that now I added 16 on the left, and that's going to give me a perfect square. And on the right, I have a perfect square, which means I didn't need to use the strategy of completing the square to solve this. And that's what I'm going to get to here. But I'm going to keep going. All right, so now I know that this trinomial factors into r plus 4 squared. Perfect square. 64 is just comes down. Take the square root of both sides. R plus 4 equals plus or minus 8. Set r plus 4 equaling 8. Set r plus 4 equal to negative 8. Subtract 4 from both sides. I'm missing my subtraction sign there. And I get r equals 4 or r equals negative 12. Now, over here, cranky face. If we had just subtracted 48 from both sides, we would have recognized that this is a factorable trinomial that factors into r minus 4, the quantity, times the quantity r plus 12, right? Negative times a positive negative. 4 times 12 is 48. Negative 4r, positive 12r gives us a positive 8r. We're good to go. And if I had set each of these equal to 0, I would have found out that r can be 4 or r can be negative 12, just like I did over here in a lot fewer steps. Okay, so when this happens for the rest of the exercises, you're going to see this cranky face guy here, because learning this system is important, but in the future, I want you to realize that it is not always the most efficient, and you should look for this when you're solving for roots. Okay. All right. Number 8. Yep, not the case here. Add 25 to both sides because half of 10 is 5. 5 squared is 25. So we add 25 to both sides. Follow the steps. We end up with the square root of 65 plus or minus the square root of 65. So then we've got to put that in our calculator. And I'm also combining a couple steps here. I am taking the square root of 65 and adding 5 to it at the same time. Here, I am taking the square root of 65 and subtracting it from 5, and it gives me that value there. All right, rounded to the nearest 100. Notice that the equal sign is an equal sign here because we are not estimating what the square root of 65 is yet. Once we put it in our calculator, we need approximately equals. All right. Number 9. Number 9 gets a cranky face because it could have been solved faster. Anyway, half of 22 is 11. 11 squared is 121. Add 121 to both sides. We end up with a perfect square of q plus 11 squared equaling 36. Take the square root of both sides, plus or minus 6, add 11, subtract 11 to positive 6, subtract 11 from negative 6, and we end up with q equaling negative 17, or negative 5. So q plus 11 equaling positive 6, subtract 11 would give us negative 5. Okay, skipped a few steps in here just for the sake of brevity. All right, 10 through 13. I'm going to crank them out pretty quick. Half of 6 is 3. 3 squared is 9. Add 9 to both sides. From here, we follow the same procedure. We end up with the square root of 18 over here. Estimate, round, approximately equals. You've got m equaling 1.24 or m equaling approximately 7.24. Again, rounded to the nearest hundredths place. 11 gets cranky face because we find out that it's a perfect square on both sides. So half of 20 is 10. 10 squared is 100. Add 100 to both sides. We find out that 361, the square root of it is 19. So we end up with r plus 10 equaling 19, or r plus 10 equaling negative 19. Subtract 10 from both sides, and we end up with r equals 9, or r equals negative 29. All right, half of 2 is 1. 1 squared is 1. This might have been confusing just because you're squaring 1, which is kind of weird because you just end up with 1. Anyway, it gets a cranky face because after you add 1 to both sides, you end up with 324 on the right-hand side, which is 18 squared. All right, follow the steps. There's my answers. Again, let me know if I made a mistake anywhere along the way. Number 13, it gets a cranky face as well. Okay, now this one, you're going to see a couple steps here. All right, so in the book, they're going to want you to add 35 to both sides so that it ends up looking like all of these, all right, where you have a binomial equaling a constant, right? And here we have a trinomial equaling 0. But, you can save yourself some time, okay? We know that this value, and I showed it here in these steps very specifically, we know this value needs to be 1 because half of 2 is 1, 1 squared is 1, right? So what I did is said, hey, the first step they're going to want me to do is to get rid of this 35 by adding 35 to both sides. And I'm also going to need to get that to a value of 1. So I'm going to do both in one shot. I'm going to add 35 for the sake of moving this term to the right-hand side. Then I'm going to add 1 so that I end up with a perfect square trinomial. So therefore, I'm adding 35 and 1. So I got 35 plus 1 is 36. This is where cranky face comes in because we have a perfect square on the left, perfect square on the right, and we didn't really need to use a completing the square. And you can see that here. This would have factored into r minus 11, the quantity times the quantity r plus no, not 11, 7, I'm sorry, to times the quantity r plus 5. So r minus 7 times the quantity r plus 5, right? I mean, you can see that now. And then, of course, we end up with the answers we end up with down here. Muy bien. Okay, so that's 13. 10 to 13. We'll try to go a little faster. Okay, so here, half of 10 is 5. So I'm using a little strategy here. Half of 10 is 5. 5 squared is 25. So I know this term has to be 25. So instead of subtracting 17 from both sides and then adding 25 later, I said, hey, what do I have to do to 17 to make it 25? I just add 8. All right, get to the same boat. You might have taken a couple steps here, and that's fine. So I end up with x plus 5, the quantity squared, equaling 8. Take the square root of both sides. And here we have our answers rounded to the nearest hundredth. I'll let you take a look. Won't have to walk you through it. Here, we get cranky face because we realize that half of 12 is 6. 6 squared is 36. If I add 25 to 11, I get 36, which means I have 25 on the right-hand side, which is a perfect square. This could have been factored, right, to very, very simply p minus 11 times the quantity p minus 1. Yeah. Anyway, there's our answers. 16 through 18. Okay. Now we're going to start getting into fractions. Now is where things start getting a little bit more complicated. Remember, if you remember from the beginning of the semester, I said any concept in mathematics can be made more complicated, thus maybe more difficult, with the introduction of decimals and fractions, right? Same problem. Now we just have to think about how all of our operations work in the context of working with fractions. So here we go, 16. Half of 3, I'm going to keep it as a rational number, is 3 over 2. 3 over 2 squared is 9 over 4. Okay, so I'm not going to try to get fancy and just add 5 and 9/4 to both sides in this case. I'm going to add 5 first, get it out of the way, then I'm going to add 9/4 later, and we end up with this. So w squared plus 3w plus 9/4 is w plus 3 over 2, the quantity squared. Okay, we good with that? Okay, good, because 3 over 2 squared is 9 over 4. W squared is exactly w squared. And then remember, perfect square binomials, you take the product of the two, so that's 3 halves w, and you double it, so then that's 6 halves times w, and 6 halves reduces to 3. Okay, got to remember that rule. So then on the right-hand side, 5 plus 9/4 is 29/4. And at this point, I had to make a decision. I had to say, okay, am I going to keep this a fraction of 29 over 4 and take the square root of it? And I decided no, because 29, it's not a perfect square. 4 is, so taking the square root of it would be fine. But 29 isn't. So I decided, you know what, I'm going to turn this into a decimal. In this case, decimals make more sense. So square root of 7.25, so 7 1/4. Oh shoot, why the heck did I all of a sudden change it to 7 1/2? That's my mistake. That should be 7.25, not 7 1/2. So this answer is not going to be correct. So if you're just listening, if you're just watching and not listening, I hope you don't have this answer, because that's not right. Okay, 17. 17. This is one of those cases where I'm going to be a little bit fancy. All right, and I'm going to keep it as a decimal. So 1/2 of m is 1/2. 1/2 squared is 1/4. So I have to add 1/4 to this binomial to make it a perfect square. And I have to get rid of this negative 28. So I'm going to do it in one shot. I'm going to add 28 and 1/4 to both sides. So when I add 28 and 1/4 to negative 28, I just get 1/4. When I add 28 and 1/4, 28 1/4 to 0, I get 28 1/4. All right, so this is a perfect square trinomial. It factors out to m plus 1/2 squared. This is square root of 28.25. We get irrational numbers. This is approximately equal. This should be approximately equal. It doesn't look like it is. No, I did not write that correctly. It should be squiggly. This should be approximately equal. But those are my values. All right. If you left this as a decimal, that's fine. That's fine here. No problem there at all. There's no advantage to leaving it as a fraction. There's just not. We will see later there are some instances where it is. Okay, so then now here we are in 18. Okay, now 18 starts throwing some pretty interesting numbers at me. All right, so we see the 682. We got to get rid of that, move it to the other side. Half of 9 is 4.25. No, excuse me, 4.5. 4.5 squared is 20.25. Okay, so I add 20.25 to both sides. Bam. So then the square root of, half of 9 is 4.5. So that's what's going here. Because, anyway, I'm not going to go over that again. So we've got this binomial squared equaling 702.25. Now, when I put 702.25 in my calculator and took the square root, I got 26.5, which is kind of interesting, right? Because this is not an approximate value, right? This isn't a rounded value. This is exactly 26.5. Okay, so I was like, all right, it's good, interesting. I didn't see that coming. I don't happen to have my, 26 and a half square value memorized, so okay, I'll go with it. So keep this as a decimal, this is a decimal, figure out our values are a equaling 22 or a equals negative 31. Now at this point I'm saying, you know what, it was very interesting with these numbers that we ended up with integer answers, 22 and 31. I'm going to take a second and test it. I'm going to say, okay, this is kind of coincidental with all of these values and decimals getting thrown everywhere that we get 22 and negative 31. So I'm going to throw it in. So in the original equation, all right, not any other version that I've done, but in the original equation, I substitute in. So 22 squared plus 9 times 22 minus 682. Threw that in my calculator all in one shot. Yep, it's 0. So I was pretty sure if that worked, this would work, but I threw it in anyway. Negative 31 squared, you can throw that in your calculator and see that it also equals 0. All right, so every once in a while, I'm not saying test every one, guys. On a test, yeah, test it. Definitely on a test. If you have time, go back and test your answers. But as you're doing the exercises, when you find a unique situation, like there was a couple of these that I threw in and I tested as well, just because I want to make sure I'm on the right track, right? That I didn't throw a weird curveball in here and mess everything up. So I put 4.82. Now in these cases, because these are estimated and that estimation gets compounded when you actually square the value up here, right? You're squaring an error, so you're making it significantly worse. Not an error, but an estimate. You don't actually get 0. You get kind of close. I think it's 0.025 or 0.25 maybe. Like you get really, really close to 0 when you substitute these values back in, but you don't get exactly 0. And it's because of the approximation to the hundredths place. Okay. All right, moving a little quicker because we're only on 19 through 20. Okay, so here, these are kinds of problems that you'll want to title. You'll want to put a title across this and say, hey, what the heck am I being asked to do here? You're being asked what value do you have to add in order to make this a perfect square trinomial. And here you can see my answer circled, but a week from now looking back at this, I'd be like, what was I trying to do? So these are the problems that they gave you in the book. Now what's kind of annoying is that you don't really, it doesn't get really complicated when you get your a value to 1. So you don't want to try to complete the square unless your a value is 1, right? Or a perfect square, but they're not going to tell you that right now. That's fine. So you want it to be 1, so then you divide everything by 2, and everything's still an integer. All right, so then this is easy. Half of 2 squared is 1. Done. Same thing here. These are all multiples of 3, so when you divide by 3 to get your a value to 1, you end up with integers again. Oh well, half of 4 is 2, 2 squared is 4. Easy. Okay. It's more complicated and more fun if your b value is actually a fraction. So anyway, moving on. Maybe that'll be a challenge question or something. All right, so 21, here's where we run into that fraction that we have to worry about. All right, so for 21, they give us this. To get our a value to 1, we need to divide by 5, which gives us a b value of 9/5. So this is how you come up with this, guys. So 1/2 of 9/5, you multiply 9/5 by 1/2, and you get 9/10. Square 9/10, you get 81 over 100. Okay. In this case, because you're over 100, it kind of makes sense to convert that to a decimal. All right, but that's not what we're being asked here. I just extra step. This is what we're being asked for. All right, so that's 21. Let's move on over to 22. So 22, here they're asking us to use this skill because they're giving us trinomials where a does not equal 1, so we have to divide everything here by 4, and everything is a multiple of 4, so I will let you follow the steps there. Those are the answers. This should be approximately equal. Looks like I'm doing it to the first one sometimes, but not to the second one. Not great. I would dock myself a point for that. Here we go. Divide by 3. Everything's multiple of 3, so we end up with integers here. Follow the same steps. Half of 4 squared is 4. Keep going. 24. Divide by 2. Everything's a multiple of 2, so we end up with integers again. Follow those steps, and we end up with x equaling 7 or equaling -2. No estimation here. And then finally 25. 25 gave us a diagram, and in that diagram, across the top, I believe, the distance was measured x, and then another distance measured x, and then another distance of 1. Across the left-hand side, we had a distance of x. The dimension was broken up into 2 pieces, a distance of x and a distance of 1. Therefore, we have an area where we multiply the length times the width. For part A, they asked for an expression. There's no equal sign here. It's just an expression. All right. We could have it equal A for area, but it would just be a variable. B, they tell us the area is 28. Now, really, I should have put units here because I recall 28 feet, but I'm not 100% sure. It would be best if I had it written in my problem. And, here we go. I ducked myself a point again. So here's the equation. All right. So then now we need to solve it. We need to get rid of this 2. So we divide everything by 2. Now I'm going to leave things as fractions right now, and I'm gambling that this is going to be helpful. It may not be, and it might have been easier for me to use decimals, but I have a feeling that fractions are going to work out, and I don't know why. And actually, it's right here at this step that I'm like, oh, yep, fractions are going to work out. So b value is 3/2, so half of that is 3/4. Square that, I get 9/16. Add 9/16 to both sides. Again, I'm taking that gamble here. I'm adding 16ths and halves. I'm like, oh, is this really going to work out? And I end up with 225/16. I recognize 225 is a perfect square. That's going to give me 15 squared, right? So it works out. So here we have x plus 3/4, the quantity squared. That's our perfect square over here. We take the square root of that. On this side, we take the square root of 225 over 16, plus or minus. Do not forget your plus or minus. That's really important. So then we take the square root. So we end up with x plus 3/4 equaling plus or minus 15 over 4. Okay? So then now everything's in fourths, so it'll be really easy to add. So here we have our binomial equaling positive, binomial equaling negative. Subtract 3/4 from both sides. Bam, bam, bam. Those are our answers. All right. Now, this is one of those that it would be mindful to throw these numbers in and check. So I did mentally. I didn't actually write it on the paper. I threw 3 up into the original problem. If I substitute that in, 2 times 3 is 6. 6 plus 1 is 7. 3 plus 1 is 4. 7 times 4 is 28. Bam. That works out. Cool. That one worked out, and threw that one in calculator, and it worked out as well. All right, so that was all the way through 25. Now, this was basically an extension of what we're doing, what we have been doing up in the from the past of solving for roots. However, we have to do this step of manipulating our trinomials so that we end up with a perfect square, so that we can use square roots. Now, I will tell you, it is possible to have a quadratic that you can't do this with. Okay, so we can't solve using square roots. We can't solve using the zero property, and we can't solve by completing the square. And I want you to think back to the past 3 sections that we've done and ask yourself, what happened to no solution? Like seriously, in section 2, no solution was like a totally viable answer. You had to be on the lookout. You graph it, you're like, oh shoot, this equation has no solution, right? And it was kind of a big deal. Now, when was the last time you had an answer for one of these problems that was no solution? It's been a while, right? It's been a while. And there's a very specific reason for that, and we're going to see that as we move into section 6, which is using the quadratic formula, the quadratic equation. Okay, so, all right, hopefully you're doing well. Again, hit me with questions. I'm not getting a lot of questions, and this is potentially confusing stuff. So let me know. All right, hope you're well.